Okay, so in A here it says that the first term of an arithmetic series, okay, so that means A, yeah, is equal to 4, and the common difference, D, is equal to 6. Show that the nth term of an arithmetic series is 6n minus 2. So if we use this here, the nth term, Tn, will be A, which is 4, plus then bracket n minus 1 times D. Okay, so you might want to write that 6 then difference at the beginning of the bracket. Okay, expand the bracket, so 6 times n is 6n, 6 times negative 1 is minus 6, so you end up having 6n, 4 take away 6 is minus 2. Okay, so there's the nth term there. In part 2 then, they are asking for the sum of the first n terms of the series is given by that. Without using the formula for the sum of the first n terms, prove that Sn is n 3n plus 1. So basically, we're going to write out Sn here, as they've given us. Put a bit of spacing here, okay, because this is like the proof formula, yeah, for the sum of n terms. But we're going to do it specifically for this particular series. Okay, so then we've got 6n minus 8 is the last but one term, and the last term is 6n minus 2. So what you do then is you reverse the order, if you remember. So you write Sn, but you reverse the order. So you put the last one first, 6n minus 2. Then you put the last but one as the second. Then dot dot dot. Then you put the second term then, which is 10, and then you put the first term here, which is 4. So you reverse the order. If you remember, you add together. So Sn plus Sn is 2Sn. Add these. Well, 6n minus 2 add 4 is 6n plus 2, isn't it? Okay, add 4 to that. Same here, 6n minus 8 add 10. That'll be 6n plus 2 plus dot dot dot. 6n minus 8 add 10 will be 6n plus 2. 6n minus 2 add 4 will be 6n plus 2. Okay, so what you find is you've got n lots of 6n minus 2, 6n plus 2. Okay, so we've got n terms here, so we've got n of them. Divide through by the 2 then. Okay, and because this is a half, and this is every term in here is even, we can multiply through by a half. Keep the n outside. 6n times a half is 3n. 2 times a half is 1. So we get exactly what they want. So in part B then, you say the 10th term of another arithmetic series is, so T10 is 4 times the 5th term. Okay. So T10 will be A plus 9D, yeah, is 4 times the 5th term, which will be A plus 4D. So A plus 9D is 4A plus 16D. So then we get, what have we got here? So 3A plus 7D is equal to 0. That's what that comes to, I think. If I get everything to one side, so that's not particularly helpful at the minute, but let's look at what else they give us. So it says the sum of the first 15 terms is 210. So 15 over 2, 2a plus 15 take away 1d is 210. So times through by the 2, which is 420. Divide by 15 is 28. So I got 2a plus 14d is 28. I could halve this, couldn't I? So if I halve this, a plus 7d is 14. And that's useful because I can get 7d from here to equal to minus 3a. If I take that over the other side. Okay. So substitute that in then. So 7d is minus 3a, which is 14. So minus 2a is 14. So that means a then is minus 7. And if a is minus 7, chuck it back in there, so d will work out to be 3. Okay, if you chuck minus 7 in there, yeah, because you'll have 7d is minus 3 times a, which is minus 7. 7's cancel, so d will be positive 3 then. Okay, good. So, what have we got left then to finish? It says, given that the kth term of the series is 200, find the value of k. So in other words, tk, the kth term, is 200. Now, remember now, what do we have for a and d? So a is minus 7, d is 3. So you use the formula a plus n minus 1d equals to the nth term. So a, which is minus 7, plus then the kth term, so k minus 1 times the difference, which is 3, equals to 200. Take the minus 7 over, so 3 bracket k minus 1 is 207. K minus 1 then will be 207 divided by 3. So k minus 1 will be 60, what are we looking at there, 69. So then that means then k will equal to 70. You take that minus 1 over.